Thanks for your interest in my new course, Geospatial Data Science with Python, GeoPandas. This is intended to be the first course in a series on geospatial data science, and topics to come will be machine learning, raster analysis, and data visualization. All of these courses will be taught using Jupyter Notebooks as a core technology. The geospatial data science approach to data analysis is quite different than traditional desktop GIS environments. In this course, we will be working with the Python GeoPandas library in a Jupyter notebook. If you're familiar with data science in Python with non-spatial data, you're probably familiar with the Pandas library. Pandas allows you to read data from a variety of formats into a Pandas data frame, which is a data structure that's similar to a spreadsheet or a database table. GeoPandas extends Pandas to read geospatial data formats and include a column in the data frame for storing vector data, as well as a number of spatial functions for working with spatial data. Jupyter Notebooks provide an interactive coding environment, which you can combine with markdown cells for rich text documentation. These can include things like headers, a variety of fonts, code blocks, hypertext links, images, and even tables. You can also include cells that contain Python code, and each cell can be run independently of the others. If you want to change a parameter, you can simply do so and rerun the cell without having to rerun the entire program. And this combination of rich text documentation and interactive Python code provides a powerful framework for analysis. As you can see, we have some nice-looking rich text documentation, including even mathematical equations, a Python code block, and some output created when that code block is executed. In this case, the output is a GeoPandas geodata frame. We know it's a geodata frame because it has this geometry column right here. And in this case, I added a field called min perimeter, which contains the perimeter of a circle that has the same area as this polygon. But you can see the process for doing that is entirely documented, so everything is explained very well. And GeoPandas is a library that provides tools for working with geospatial data. This includes input and output from a variety of file-based data or from PostGIS and from other formats as well. Pandas can read just about any kind of geospatial data because it uses GDAL and Ogre in the backend for dealing with data input and output. And GeoPandas includes spatial functions for dealing with spatial data. These include functions for measuring distance and area, for testing spatial relationships, for creating new geometries by buffering, intersections, clipping, dissolving, etc., as well as fully featured overlay functionality like you might find in a desktop GIS. And if you're familiar with PostGIS SQL, this is similar to the way that PostGIS provides spatial functions for dealing with spatial data. Although I would argue that GeoPandas has a richer set of functions than even PostGIS. And Pandas has amazing tools for data manipulation, doing things like merging, joining, appending, replacing values, data cleaning, dealing with missing data, and more. It also includes some simple tools for plotting out your spatial data in the form of simple maps. It's not a cartography tool, however, and if cartography is your primary use of GIS, this approach may not be for you. As you can see, we can specify colors, adjust transparency, include boundaries on polygons, etc. And we can create fairly complex mapping products. And GeoPandas also integrates well with other Python-based tools, including those used for machine learning and scientific programming. The advantages of the data science approach include documenting every step of your analysis. And this is very important for scientific applications or in applications with legal consequences that might be challenged in court. Also very useful for teaching, as you'll see in this course. And even if this doesn't apply to you, documentation is very useful when you need to collaborate with colleagues or simply to be able to remind yourself what you did a year or two ago. And Jupyter Notebooks makes that very easy. Another advantage is that the coding is interactive. You can see your results immediately, every step along the way, and adjust accordingly. We can also collaborate with other people by sharing notebooks, and those people will be able to run your code against your own data if you provide it to them, just so they can see how everything works, or they could substitute their own data if they simply wanted to repeat your analysis for themselves. And Jupyter notebooks run in memory, so they're very fast. NumPy handles all the background calculations, and so it's highly optimized. If your computer is not fast enough, there are methods available to parallelize your code to take advantage of multi-core processors, or you could even spin up a cluster in the cloud and run there. And big data platforms such as Amazon Aurora or Google BigQuery have notebook interfaces as well. So you can be working on your desktop in a Jupyter notebook and be working with code in one of these big data platforms running on a very powerful computer that's highly optimized. And essentially, there's really no limits in the geospatial data science approach. When new analytical techniques become available, they'll probably be implemented in Python first, and it might be years before those techniques trickle down to your desktop GIS software, if they ever do. But if you're familiar with this approach, you won't have to wait until that happens. And if you're working with large amounts of data and need a lot of processing power, like I said, you can spin up an instance of Google BigQuery or some other cloud-based big data platform and run your analysis there. But the interface, the Jupyter Notebook, will be the same. One of my favorite things about GeoPandas is that it's so easy to rerun your analysis or part of your analysis. Everything is done in memory, and there's no need to create files on disk at every intermediate step, which serve no purpose and just clog up your hard drive. Instead, you can just rerun your analysis to get back to where you left off without creating new files. If your data changes, just rerun your analysis. If a colleague wants to perform your analysis on their data, again, they can just change the inputs and rerun your analysis on a different set of data. So there's no need to go through a complex set of choosing items from menus and setting parameters in a GUI, which can take significant time. Just change a few parameters that you need and run everything again in one step. There are some disadvantages as well, I'm not going to lie to you. I would say that GeoPandas is not a replacement for desktop GIS. I expect I'll always have desktop GIS on my computer, and it works great for everyday managing of GIS data, exploring your data, and things like that. And although you can produce some fairly impressive cartographic results, this is not a tool for mapping. And if that is your primary interest in GIS, then GeoPandas may not be for you. It's also not a great tool at managing data. If most of what you do is digitizing data, entering new data, or exploring your data by panning through a canvas and clicking on items to see their attributes and things like that, then you're probably better off in a desktop GIS. But when it comes down to analysis, I've learned to just love working with GeoPandas. Like I said, I imagine I'll always have a desktop GIS available, but these days when I'm faced with a complex series of steps to perform, I almost always do it with Jupyter Notebooks. So if you want to see what all the hype is about, simply find this course on udemy.com. There's also a link in the video description for this video, and use the code GeoPandas and sign up. It's available for only $9.99 through January 1st with that coupon code.